We now want to understand in a little bit more detail how this function fread works by looking at 4 particularly common optional arguments that you can use in practice to import more untidy or more dirty raw data that you might encounter quite frequently. All of these steps are also documented in the tutorial on data import that I provide on the course homepage. So if you want to get some more details or reread what I'm saying here, you can have a look on that. So the goal is to learn a little bit what you can do when the standard call of fread that we've used in the first exercises doesn't produce the result you actually want. And to this end, we will have a look at 4 quite common optional arguments that you can use. Before we go into that, first, the file argument, that's not optional, that's mandatory. Yeah, that's the relative path to the CSV file that you want to read in. Always combine it with a here function from the here package. That's what we already did. Then there's a second argument, sep, that you can use to specify the symbol that separates the columns. So you might know, why comma separated values is what CSV stands for. So shouldn't the columns be separated by commas all the time? Unfortunately, it's not the case. There are some countries, including my home country, which have different conventions. So at sometimes you need to be specific with regard to the symbol that separates the columns, and the sep argument allows you to do so. There's a related argument dec, which is a symbol that can be used to specify how the decimal parts of numbers are separated from the integer parts. So 2.4 has a decimal part, 0.4. And well, again, different countries might use different signs to do so, and different people might even decide to use a completely different sign to actually separate the decimal part of a number. So in some situations, you might be forced to specify it on your own. And then lastly, there's this optional argument call classes. This allows you to specify what kind of object is about to be used in R to encode the different columns of the data set you import. So you might have figured out in the previous example that R has automatically chosen to encode the different columns in, I don't know, the double format, the integer format, based on what is written in the data set. Most of the time, that works quite fine, but in some situations, especially when we use some particular codes in the underlying data, R might guess a column is actually representing numbers and therefore uses the double code or the double object type for this column in R. But what you actually want is this column to be formatted as a character string. And this optional argument call classes allows you to consider this when importing the data. There are other widely used commands. Some of them are touched upon in the tutorial and in the exercises that come with this session. In any case, you can have a look at the help function from fread that explains everything. But I guess in the beginning, it's probably a good idea to learn about these 4 arguments, 3 of which are optional, to get a feeling of how fread actually works. And here we want to start with this optional argument sep that allows you to specify the symbol that separates the columns. So here's an example for a data set that's actually typical for well, at least partly typical for my home country, Germany, because, well, it deviates from what you would have expected from a CSV file. As I said, CSV, comma, separated values. That's the file format. If you look at the 4 columns here, C code, year, exports, unemployment, you will see that they are not separated by a comma, but by a semicolon. Usually R is so smart to actually figure that out on its own. But this is just one example of how a data set could look like, or how a data set could deviate from what we would usually expect. So here, as I said, the columns are separated by a semicolon instead of a comma. So to be very explicit here, we can pass a string to the sep argument indicating how these columns are separated. In this case, we would need to tell our, hey, columns are separated by a semicolon, so use the argument sep equals semicolon. Semicolon here, of course, supplied as a string, and by doing this, we are explicit also to the people who read our scripts with regard to how the underlying raw data looks like, and we also make sure that the imported tibble or data frame has its columns formatted in the right way. So in this sense, it's always a good idea to first have a look at the underlying raw data, and then based on what you see there, specify these optional arguments in fread accordingly. Very similarly, similar approach with regard to the dec argument. Here is an example for a data set that is slightly different than the first one. Again, here the columns are separated by semicolons, so we would need to use the sep arguments. But if you look at the third and fourth row column, you also see that now the decimal sign is not a point, but a comma. Again, in Germany, that's quite typical to separate the decimal places via a comma instead of a point. This is also why the columns are separated by semicolons, not by commas. So in this case, we can use, again, a string, pass it to dec, indicating how the columns are separated. Here, because the decimal places are separated by a comma, we use dec equals comma. Very straightforward. Good. So let's now import the dataset fread examples 2 into your project that you've set up before. And the task is here to import this dataset in a way that the following tibble results. Small hint in the beginning, this is a little bit an artificial dataset to make sure that fread does not get it right on its own. Here you need to set some optional arguments on your own. So it's nothing that you might find in practice like this, but it simulates a situation where dec and sep at least need to be set by you explicitly.